We're solving problem 22 from the MC12A from 2023 with two solutions. Let f be the unique function defined on the positive integers such that this sum equals 1 for all positive integers n, where the sum is taken over all positive divisors of n. What is f of 2023? So we want to set up an equation for f of 2023 to help us visualize this. We know that 2023 is equal to 17 squared times 7. That's one of the ways you can prepare for one of your next math competitions, by knowing what your number is. And we see that 7 is a prime and 17 squared is a prime too. If we find this of a prime, it's like saying all the factors, you add up all the factors. This notation is kind of weird, but say if we have a prime, we can express that as all the factors multiplying it. So a prime is equal to 1 times itself. So there's a factor 1 times this value f of the prime, p, say that, and then you have to add the sum of p times f of 1 equals 1. And this is basically it, where we take out all the factors of the number where you're trying to find the function of and multiply it by what's left when you divide it. We get that since we know that f of 1 equals 1, we know that f of p is equal to 1 minus p. We have that. Now, this is in the form of pq squared, so let's just find what f of pq is. Well, let's just find that first. Or we could do another square. So let's just do f of pq. F of pq, what is that? Well, that's clearly one factor. You add the f, you have to add the q times f of p, and then you add the p times f of q, and then you have to add pq. Now, this is being multiplied by f of p1, well no, just f of 1, but we already know that f of 1 is 1, and we know that this is all equal to 1. Okay, now we can start plugging in these equations from earlier to get a value of f of pq. So, what do we know? If we subtract all of this from that side, we can get an equation for f of pq, or just subtract the 1. F of pq is 1 plus q of p minus 1 plus p times q minus 1 minus pq. We subtract it from all that side. That is what we get when we plug in f of p is equal to 1 minus p. So we now have this. We can drastically simplify it into 1 minus p times 1 minus q. We have f of pq equals this. So this is interesting. Now we want to find f of p squared. Let's do that. F of p squared is f of p squared plus p times f of p plus p squared. Again, because f of 1 equals 1, this equals 1. Now, if we subtract everything from that side, you simplify everything down by, again, plugging in f of p is equal to 1 minus p. F of p squared is equal to 1 minus p. How interesting. We have f of p squared, f of pq, and f of p. Now we can solve for f of pq squared, which is in the form of 2023, because we have a prime here and another prime that is squared. If we use the same logic, f of pq squared is equal to f of pq squared plus q of f of pq plus p times f of q squared plus q squared of f of p. We have that, and then you keep on adding the factors. There's more, plus pq times f of q plus pq squared equal to 1. After simplifying it all down by simply plugging in the respective values for the f of pq's, q's, squares, and p, we get that f of pq squared is equal to 1 minus p times 1 minus q. Since we have our primes, the p's and our q's value here, we know that the q value in this instance is 17 because that's the square. So this is 1 minus 17, negative 16 times 1 minus 7, negative 6. That is our answer of 96. And we're going to go into our next solution.